Hello everybody. Today what we're going to do is we're going to cover one of our last videos here on the periodic table. Today what we're going to talk about is how each family on the periodic table has their own particular family name, and so that's what we're going to cover because each family has their own particular reactivity, and so each family has been assigned its own name. So we'll get into that. So first of all, we're going to start off here with the main group elements. And so if you think about the periodic table, you have two columns that are up high, and then you have this middle section, and then you go back up and it's high up again, and it comes down here like so, and then you have these bottom two pull-out row. The main group elements are these elements that are in these top high up sections, okay? The middle sections are not part of that, okay? These middle sections right here, okay? These middle sections are called the transition elements. And these red ones are called the main group elements. So that's what I'm getting at when you think about the periodic table, okay? So we'll run through the notes here first, and then we will go to the periodic table, and I will draw on there and show you which each family or each column or each group is called. So we've got alkali metals is group number 1, okay? They have 1 electron in their outer shell. The big thing that I want you to take away here is that they are very active metals. They are the most reactive metals that you are going to find, okay? They're so reactive that they will react with the air that is in them. They will react with the water that is in the air, and because of that, they have to be stored under kerosene or mineral oil because they're so reactive to water, okay? The next group is the alkaline earth metals, okay? They have 2 electrons in their outer shell, and because they have 2 electrons versus 1, they're stronger, denser, harder. They have higher melting points than that of group 1, okay? Then we move into the transition elements, and so those are the ones that I just showed you up here at the top, okay? That middle section. They form very colorful compounds. They're pretty unreactive, and then the big thing that's kind of unique with them is that they form multiple charges. Sometimes they're a +1, sometimes they're a +2, okay? So that's kind of unique to them. The lanthanides and actinides, these are the bottom 2, the pull-out rows, okay? Those 2 pull-out rows that we pull out so that we fit on an 8.5 by 11 sheet of paper, those are called the lanthanides and actinides. Group 17 is the halogens. The thing I want you to take away from there, they are the most reactive non-metals, okay? So up here, the alkali metals are the most reactive metals, okay? Where the halogens are the most reactive non-metals. So there's the big difference here. The noble gases have their outermost energy level completely full, and because of that, they are the least reactive metals that you have there, okay? And then we have little hydrogen. Hydrogen is in a class all by itself. It does not share properties with any other element, but we had to put it somewhere on the periodic table, and we put it with group number 1 because it has 1 valence electron, so we put it with the alkali metals with the 1 valence electron, but it is unique all by itself, and it doesn't have any properties anywhere else, okay? Where did the elements come from? There are 93 naturally occurring elements. Three of them, technetium, promethium, and neptunium, are not found on Earth but have been detected in stars. How do you get some non-natural or man-made elements? You can do a nuclear reaction where you change the composition of the nucleus either by fission or fusion, and that's what transmutation is changing the nucleus by either disintegration or bombardment with other particles, and that's what we've got right here. Fission or fusion. Fission is splitting the atom, the most common one with the atom smasher, or the fusion. Take two atoms, join them together to make one larger one, and that's what happens in the sun. 4 hydrogen atoms to make 2 helium. Man-made elements are highly unstable, okay? They're very radioactive and they degrade very quickly, some lasting only a few microseconds, just long enough to be detected, and then they are disintegrated. They are trying to reach an island of stability where the number of protons and neutrons are more stable and they won't degrade as quickly. The island of stability is believed to be at 114. We have reached the island of stability. It is believed, it was confirmed, and it did last a little longer. And then they are now reaching out to a new island of stability, although I do not know what that new island of stability is at the top of my head. But they are reaching out to a new one. But they are still working with smashing atoms together and creating more and more elements. But again, all of these man-made ones are very unstable, just long enough to be detected. And that is it for the note packet. So now what we're going to do is we're going to go to our periodic table and we're going to make our periodic table all pretty. Okay? So let's go here to the periodic table. And we are going to start here, and I'm going to do this in red. And I'm going to do the alkali metals. And the alkali metals are column 1, but do not include hydrogen. Because again, hydrogen is in a class all by itself, but we had to put it somewhere. So we put it in column 1 because column 1 all has 1 valence electron. Okay. Then column number 2 is the alkaline earth metals. And this is column number 1 or number 2. Okay. Then in green, I'm going to do the transition metals. And they are this inner chunk. Okay. Now, these bottom 2 pull-out rows, okay, I am not going to color them green, although they are transition metals, okay? I could actually color them green, okay? But they have other names that are more specific. And since they have a more specific name yet, I'm going to wait and give them those names rather than color them green with transition metals, because I can give them a more specific name. But you could technically call them a transition metal. It would not be wrong to say that these bottom 2 pull-out rows are a transition metal. So let's give them their name, and I'll go and I'll give this in orange. So here we go. Let's do the lanthanite, okay? And the lanthanides are the top row down here. Color that orange. Okay. And then pink, I'm going to do the actinides. And I'm going to move my picture here of me so you can see all the actinides, because the actinides are all at the bottom down here. Okay. In yellow, I'm going to put the halogens. Put the halogens in yellow. And again, I could go about blocking off 113 to 118 again, because properties haven't been fully isolated. And then I need another color for my noble gases. Let's see what other color I've got to choose from. Don't really have much choice, so I'll go with a deep navy blue here. Okay, and this will be my noble gases, which is this okay. And then we have these other columns, these other groups, the ones that start with boron, carbon, nitrogen, and oxygen. They have really boring names, okay? I'm not going to color them, but I'm going to write what their names are up above, okay? The column with boron, aluminum, gallium, indium, and thallium, those are belonging to what is called the boron family. Next one over is a member of the carbon family. And I bet you can guess the next one. And if you guessed the nitrogen family, you are correct. And the next one over, you probably can guess, but it happens to be the oxygen family. See, I told you, boring names. And look at how pretty we have. And then we have sad little oxygen in brown, all by its little lonesome self in a property all by itself, doesn't recognize anything else like it, all by itself. And there's our pretty periodic table. And there we are done creating our periodic table. Hope you had some fun doing some coloring. And there we go. Good luck finding trends and periods and patterns and all sorts of fun discoveries with the periodic table. Good luck, ask questions, and there we go. This ends this video.